So we're going to use calculus to graph the function x cubed minus 9x squared plus 24x plus 3. We're going to find the intervals of increase and decrease, the relative extrema, the intervals of concavity, and the inflection points. Now the first two things, finding intervals of increase and decrease and relative extrema, come from our first derivative. So let's take our first derivative of this, and I'm going to use the draw feature just to make this a little bit easier. All right, so my first derivative, of course, using our general power rule, we'll get derivative of x cubed is 3x squared negative 18x and for 24x we'll just get 24, and of course the 3's derivative is 0, so it's going to go away. Now the first thing we want to do is set this first derivative to 0 and find what are known as our critical values, or our first order critical values, because they come from this first derivative. So if I set this to 0, let's notice first of all that every term is divisible by 3. So this thing will be easier to factor if I can get the 3 out of there. So I'm just going to divide everything by 3. And that's going to give me x squared minus 6x plus 8, which does factor nicely. And that factors as x minus 2, x minus 4. And then, of course, if we set both of these factors to 0, we get our two first-order critical values. This one is 2, and this one is 4. All right, now what we're going to do is we're going to draw a number line, and we're going to put these on the number line in their normal order on the number line. So 2 would of course occur first, and then 4. All right, now this represents the entire number line. If I want to, I can put arrows at the end. But what we're going to do is choose something to the left of our 2 first. So for example, I could choose 0, that's to the left of 2. Go back to where I have this factored and plug in 0. I'd have 0 minus 2, that's negative, and then I'd have 0 minus 4, that's negative also. And a negative times a negative is a positive. And I'm going to put that sign over here. And the truth is, anything that I chose over here on the left would lead me to a positive answer up here. So even if I chose -1, I'd have negative here, and a negative here, and a negative times a negative would be positive. So it doesn't matter what I choose, as long as it's to the left of the 2. Now I'm going to choose something that's in between the 2 and the 4. 3 is a nice whole number that's in there, so I'll choose 3. 3 minus 2 is positive. 3 minus 4, however, is negative. So a positive times a negative is going to give me a negative answer. Anything I choose in here will be negative. Now, I could have chosen anything. I could have chosen 2.5 if I wanted to. When I plugged it in here, again, I would have gotten a negative answer. And let's choose something over to the right of 4. We can choose 5, we could choose 6, doesn't really matter. I'll just choose 5. 5 minus 2 is going to give me a positive. 5 minus 4 is going to give me a positive. A positive times a positive is a positive. Okay, now this little sign chart we've made determines where our graph is increasing and where it is decreasing. When we have a positive, that indicates an increasing interval. When we have a negative, that indicates a decreasing interval. So for us, negative infinity to 2, notice has a positive over the top of it. And then also 4 to infinity has a positive over the top of it. These are our increasing intervals. All right, now let's write our decreasing one. That's from 2 to 4, where we have a negative over the top of it. All right, now, also from this sign chart, we can tell where maximums and minimums occur. So let's just think about this. Up until the 2, it's an increasing graph, so it's doing this, it's going up. And then after the 2, it's a decreasing graph, so it's going down. And notice that forms a peak when we think about that. So that is where a max occurs. Now, before 4, it's decreasing, and then after 4, it's going up. So we can see that that's kind of a valley there. So we're going to have a minimum at 4. Okay, now, those are where our max and min occur as far as the x value is concerned. We do need to get the y value, so we can plug this onto a graph in a few minutes. So to get the y value, we are going to plug these back into the original, not the derivative, but the original, to get their y values. So I'll go back to my original function and plug a 2 in way back here at the top. So I'll have 2 to the third minus 9 times 2 squared plus 24 times 2 plus 3. So when I plug the 2 back into the original function, I get 23. So 23 is the y value of my maximum. And then, of course, I plug the 4 back into the original function. And when I stick this into my calculator, I get 19. And that was our minimum. Now, that's everything that we can get with our first derivative. We've gotten the intervals of increasing and decreasing. We've got our maximum and our minimum. Now we're going to use the second derivative to find concavity. And the second derivative always gives us concavity and inflection points. We'll see that the process, though, the same thing that we did with the first derivative, we're going to do with the second derivative. It just gives us different things. All right, so let's go back up here to the top and make sure we get the original first derivative. So 3x squared minus 18x plus 24 is what we're going to take our next derivative of. We've got to be careful that we don't use the part where we divide it out. So 3x squared minus 18x plus 24 is going to give me 6x minus 18 as a second derivative. So let's come down here. So our second derivative was 6x minus 18. And just as we did with the first derivative, we're going to set that to 0 and solve that equation. So take our 18 over and divide by 6. And we get the only second order critical value is 3. Let's put that on its own number line. And just as we did with the first derivative, we're going to choose something over on this side of 3 and something over on this side of 3. So I'll choose over here on the left of 3 a 0. If I put 0 into the second derivative, 6 times 0 minus 18 is negative. Everything over here will be negative. If I put something on this side of 3, let's say 5. If I put 5 in to my second derivative, 6 times 5 is 30 minus 18. That is positive. Now, our second derivative gives us concavity and inflection points. If the sign changes across the critical value, as long as this is not undefined in the original graph, then we have an inflection point. And 3 is defined, and since our graph is a polynomial, so this is an inflection point. Now we'll see some cases later when we look at rational functions where this could be a vertical asymptote. So that's one of my inflection points. Now to the left of 3, the second derivative is negative, which indicates that from negative infinity to 3, this graph is concave down. And then on this side, where we have a positive, the graph is concave up. Just going to abbreviate for the sake of expediency there. All right, now, just as we did with our extrema in the second derivative, we want to plug this critical order, this critical value back into the original to get its y value. And it will also help to flesh out our graph. So we want to plug the 3 back to the original. Always go back to the original for y values. So if I plug that back into the original function, it'll be 3 to the third, 9 times 3 squared, 24 times 3, plus 3, and then we'll put that into our calculator. And that gives me 21. All right, and that was my inflection point. So last step is to actually graph this thing with all the information that we have. So let's start with the 3 points that we have. We have 223, 419, and 321. So I'm going to plot those first. And I don't need to scale my x-axis in any special way. I can do it by ones. But I do need to scale my y-axis because my values go up to 20-something. So I'm just going to scale it by 5. We can always scale the y-axis. So if we get things up in the hundreds, we can just scale it. And of course, since I'm drawing on here, this is not going to be perfect. Drawing with your mouse is an acquired skill for certain. Okay, so we have the point 223, that is our max. Let's plot that first. 223 is about, there. We have the point 419, that is our min. 419 in here. And then we have the inflection point 321. 321, right in there. All right, now if we look back, we have that this function is increasing from negative infinity up to 2, negative infinity to 2, and it is concave down during that time. So let's draw it increasing up to this graph and increasing, up to that point, not that graph. All right, now when it gets to 2, according to our information, it starts to decrease from 2 until 4. Until it gets to 3, it remains concave down. So it's decreasing but concave down, so we still want that downward U shape as it comes down. Now right when it gets to 3, it becomes concave up. So still decreasing, but let's make it an upward U shape. And now, when it gets to 4, according to our first derivative information, it's increasing again. So it's increasing again. There's the shape of our graph. Now, if we wanted to, we could perhaps figure out what this x-intercept is down here, but that would be kind of difficult since we have a cubic function, so that's not necessary. We get the general shape of our graph from our first and our second derivative.